Alright, so let's continue. As all of you have understood earlier, we basically started working on word count program. It's our first MapReduce program that we started working on, and then we basically tried to execute that as well. I'll be covering one more concept on the word count program, which is basically called a combiner. Okay, very useful concept. Let us start with that. Okay, so as you can see here, we understood this word count problem where word and the occurrence of that word is what we write it as an output from the map task, from each map task, and from there basically it goes to the shuffle and sort. All the values of that word will be combined, and then basically it goes to the reducer where you are trying to sum up all the values for that word and write that output. Okay, so that is what we are doing. Now, in this particular problem that we understood, if you observe here, what we are doing, we are basically transferring so many records over a network, right? Here, if you notice, this is the output generated by map1, map2, and map3, and all of this data is transferred over a network, right? And then it is combined for a given key. Now assume that, let's say I have 1 million orange key available in this file, 1 million. Okay, orange comma 1 comes. So in that case, since the orange word comes as 1 million times in the file, I will be transferring this data to the shuffle and sort phase so many times, and it actually combines the data accordingly, right? So basically what does that mean? That means that it actually have to occupy too much network bandwidth, right? As you all can see, I'm transferring data over a network during shuffle and sort phase. So here you have 1 million, that's fine, but to do that you need to basically transfer so many data over a network, right? So that actually increases the bandwidth usage in the network, and accordingly it decreases the performance, right? So which is really not very efficient in terms of MapReduce. So when you have too many keys and values which are being transferred over a network in a map task, definitely it's consuming a lot of network bandwidth, and which is definitely not good for the performance of the MapReduce program. Okay, so to avoid that, what we need to do is we are basically doing another thing where we take this reducer. See, in reducer and what we are doing, we are combining all the values. We are calculating the sum of all the values for the given key. So can you assume that if this reducer logic, which take the sum of all the values for the given key after shuffle and sort happens, if the same logic, what if I will apply it to each and every output which is being generated from each and every map task, right? So now what happens? You have orange comma 1 here, 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 and here. So it becomes orange comma 4. Instead of sending 4 times orange comma 1, you have orange comma 4, and here you get orange comma 1 again. So it becomes orange comma 2. Okay, and here orange comma 2. Right, and then what happens? This is the key which is being transferred over a network to the shuffle and sort phase. So here it becomes orange 4, 2, 2, right? The whole advantage you are getting is, instead of transferring 4 times orange comma 1, which occupies more network bandwidth, I'm just transferring once orange comma 4. So I'm actually locally reducing this data in the local machine of the map task output itself. Okay, same way for 2 and 3, output 2 and 3. So that is how it is combined, and then this is what will be given as an input to the reducer. So reducer, what it does, it will iterate through these values and take the sum of it. So 4 plus 2 plus 2 will give you 8, right? So this is your final output which is being generated. Okay, so what happens here is, We are, see, if you notice in the earlier case where we were not using combiner and this case where we are using combiner, the final output is actually not likely to change. If you use a combiner, earlier case we don't use a combiner, so we got orange comma 8 as a final output. If you use a combiner, then 4, 2, 2. But again, if you take the sum of it in the reducer, 4 plus 2 plus 2 will give you 8. So orange comma 8 is the final answer, which means the final output, even after using a combiner, will not change. So that is the scenario where combiner can be used. Okay. So you need to be very careful where do you use combiner, where do you not use combiner. You can't use combiner in each and every MapReduce program. Not possible. You need to use a combiner for those programs where it will not change the final output even after using a combiner. So it has to be commutative and associative operations. Okay. Combiner runs first. It actually combines the data and then it goes to the shuffle sort to combine it again further. So in fact, sorting happens here as well, before you combine, here as well, before you combine, and then after combining also sorting happens. Sorting is a way of merging the data, right? It's an efficient way of merging the array of words in the same or in the different array, right? So if two words, let's say orange and apple, if two words are there and I want to sort them and I want to combine, let's say orange are there, apple are there, but I want to sort and combine. So I can actually use a sorting logic which basically what it does is it tries to combine all the values of the same key in a much more efficient manner, because n log n is the complexity in which it can achieve that. So it is faster. Okay. So when you should use a combiner, and that's what I said, it's very important that when you use a combiner, it should not change the final output. In this case, word count, if you see without combiner, it was generating a count as 8 for oranges. Even after combiner, it will generate the same count. So in those cases where it is not changing the final output, you should definitely use a combiner to reduce the network traffic. Okay. But for example, let's say there is another example that I want to give you. Let's say there is a file, okay? A file which contains just some numbers, 10, 20, 30. Let me explain it differently here. Let's say there are file with 7, 8 numbers, okay? Now what happens? I want to calculate the average of this number. That's my problem statement. Now the file could be having 1 million number or 1 million number, it doesn't matter. It should actually calculate the average of all the numbers efficiently. Okay. So what I want to do is normally to write this program and okay, so what I have drawn is, this is my file which contains those numbers, okay, 10, 20, 30, 40, 50, 60, 70, and these numbers, I want to take the average of this number. This is my problem statement, this is my data set. So when you write a program, right, what we need to do is, in the mapper logic, I need to actually write an output in such a manner that all the values will go to one key basically. Why? Because you want to do the average. So if you notice here, I just have one number. How do I take key and value? So normally in this example, what people do is people take constant as a key and value is 10. So basically, whatever is the number, I'm taking that as a value, and the key will be the constant key. Okay, it will not be changed. Now, when this is your mapper output, what happens? In shuffle and sort, you combine them. So what happens? All the values of the same key will be grouped together. So these numbers are combined in shuffle and sort phase. And then in reducer, what you do, just iterate through this number and take the average. The reason why I am taking constant key in this example, because I want all the numbers to be given for the same key, so that I can calculate the sum and then find the average. Okay. So that is the problem statement. Say the problem statement is it has found out the average salary of all the let's say employees. Now, once you have this number, I want to also find out one important thing, which is we have taken the average. Now that is the code that you normally write it in the reducer end. So can we say that if I apply this reducer code to every map task, right? So because I want to use it as a combiner. So what happens here? It actually tries to here, okay, in here, let's take this average, by the way, sorry, 10 plus 20, 30, 40, 50, 60, 70, total sum is 280, divided by 7 is 40, correct? And if you take that as a combiner, what happens? Let's say these are the 3 data comes in reducer, and these are the 4 data comes, sorry, these are the 3 data in mapper 1 output, this is mapper 2 output. If you apply a combiner, what happens? 10, 20, 30 is 60 by 3 is 20. And this guy is 100 and 220 by 4. So 55. So total is 75 by 2, which comes around 37.5, which is definitely not equal to 40. So what we are trying to do is, I'm just explaining you an example where if you use a in this example I can't use a combiner because if I'm taking average of number. Now if you take a combiner here, the same reducer code, if I apply it at every mapper output, what happens? You are taking average of average, which doesn't give you final average. So obviously your final result will be different. So here combiner should not be used. Okay. So is that clear now? Where to use combiner, where not to use a combiner? Any questions on this? All right. So I think that's all we should remember, and we should move forward now. So let me go ahead and explain you where we can use a combiner. So this is a MapReduce program that we have written, right, on the Friday's class. So I'll again re-execute it. Why? Because I want to show you the difference when you use a combiner and when you don't use a combiner. Okay. So let me re-execute this program and we'll see the difference. So I think I have a data. Let me go to the HDFS and see the data. Yes, there is a fruits file available. The same data I will be using. So I'll just say Hadoop jar mr.jar and the class name. It's a qualified class name. Package.class name. The input file and the output folder. I'll write it. Let me create an output folder. I'll create an output folder as MapReduce so that we'll be writing all the output here itself. Okay, so WC output is what I'm writing. This is my code, and once I execute it, we all know that it is going to count the occurrence of all the words and print the output. But we want to now see some more important information about that program, and then we'll see where we can use a combiner. So here basically we are actually seeing all the data. As you can see that there are different counters printed here. There are some job counters, some file counters, how many records are read and processed, and there are some MapReduce counter as well. Each record is processed in map phase as well as reduce phase. So how many numbers of records are processed? We need to focus on this property only, which is called reduce shuffle bytes. As you can see, reduce shuffle bytes is 2881 which means that many number of data is transferred over a network from mapper to shuffle and sort. Okay. So our objective to use a combiner is to reduce this particular property value, which means earlier it is 2881, now it should be reduced to some other number. That's the objective, okay? And if you see here, there is no combine input and output record right now because no combiner has run. But after running a combiner, we should get some records here. So this is the change I want to see in my program so that we can say that yes, it has improved the performance of my program. So let me go ahead and make that change in the program. So what is the change? We need to actually make a lot of changes, in fact, to enable a combiner. A lot of lines of code you need to write. That's it, done. This is the combiner that you are enabling in your MapReduce program. I'm just saying Hadoop framework in my driver code that please use WC reducer as a combiner code. Done. Okay. After that, you don't need to do any other changes. Automatically, it will run your reducer code as a local or mini reducer after every MapReduce output. So I'll be going here. I'll be exporting a jar. Okay. Let me just re-execute that program. Okay. So let me take this, copy this. And I'll now store the output into another directory. Everything else remains the same. Let us execute this guy. So as you can see that it is completed, and this time reduce shuffle byte is 82. Earlier in this example, it was 2881 without using a combiner. Now with using a combiner, it has come down to just 82. That's the difference you can make when you use a combiner. And that much amount of data you can reduce by transferring over a network. Okay. And you can also see that there are so many combined input and output records which has come. Shibani, every job when you execute, right, there will be a time which is specified on the logs, or here also on the job stack itself you can get the time of the execution. Okay, and you can get to see that from here. Actually there is a counter where you can get all the time. Okay, so this is your time to get to check how much time it took to run that job. Or you can actually go to the YARN resource manager. I'll show you how to see the log file, but right now you can go to the YARN resource manager, pick on any of the MapReduce program that you have executed, and then it will basically show you the statistics of this job. You can just see this start time and end time. So this is your total time which is taken by a particular job. So as you can see, Shibani, time is taken as 41 job. What was the time difference? Okay, so you take the time difference like this, no, between both the job. And that's how you can see the difference. Since this was a small data set, you may not be able to see total. Yeah, I think it is 41 seconds. And earlier job without that should be something more than that. Yeah, this was the combiner, and that one is a non-combiner. So it took 36 seconds. Non-combiner took 41 seconds. Since it was a smaller data set, you don't really see much difference in terms of execution. But if it is too much data, then you start seeing that huge difference. Okay. So this was the code change that I have made, Mintesh. Job.set combiner class as reducer class. Now let us move forward and understand another problem, okay, which is with respect to partitions. I'll show you how to do the partitions in MapReduce. It's a very, very interesting and important concepts. For partitioner example, I have taken very simple data set, okay, because if you take simple data set and try to solve a problem, you can understand concept easily. Then we can actually easily understand how to apply it for a huge data set as well. So let's say I have this data set where I want to use a partitioner. What does partitioner do, by the way? That is what we need to understand. But before I go there, let us take a problem, and through problem itself, let us understand why do we need partitioner, when do we use it, and when do we customize the partitioner. So it will become much more clearer. Okay. So let's say this is my data set. I have 4 columns: a user ID, username, whether that user is permanent or contract, and what is the salary he or she is drawing here. Okay. That is the problem, that is the data set we have, and we want to solve that particular example. So let's say how do we solve that? So here, let's say the problem statement that I want to solve is, I want to find out average salary of a permanent employees and average salary of a contract employees in the company. Okay, so you have to go through all the employees who are permanent, get their salary, take the average, give me that average. Same way, get the average of a contract and put it in the file. So basically we want to find out average salary of all permanent employees and all contract employees. So how are we basically going to solve that? Okay, let's say we need to use a MapReduce. So can anyone tell me what should be the key and value I should take to solve this problem? You need to use permanent as or contract as a key and value is salary. Very good, right? So let me draw this diagram to explain the same thing. So we know that we have something called mapper face, right? In that, what do we have? A key as permanent, value as salary. So let's take some example. Let's say we are processing every line. Map method will be running for every record, and it will be writing the output something like this: permanent, comma 100. Okay, let's say permanent, comma 200, contract, comma 300. This and let's say contract, comma 400. This is my first mapper task. And the map 2 will have, let's say, permanent, comma 200, permanent, comma 300, contract, comma 100, and contract, comma 150. Let's say this is the map 2 output. This is map 1 output. We can assume it that way, right? This is how we write the output. Once that output is written, then what happens? It will go to the shuffle and sort phase. So you will have shuffle and sort phase where we will basically combine all the values of the same key. It will be something like this: 100, 200, 200, and 300. Basically these things. These are the values which I am going to combine, correct? For the same key. Similarly, you will have contract, comma 300, 400, 100, 150. This is how it will be combined, right? And after that, it goes to the reducer, where reducer is going to, let's say you have reducer 1. The same reducer, when it goes, it will again run for a key value pair. Reduce method will run. So all the values for the same key, reducer method will iterate through this and then take the average. So that is what it writes here: permanent, comma average, and of course contract, comma average, right? This is the output. This will be my final output file which I am expecting, right? So we'll first write this program to solve this problem, and then we'll move forward. Okay, I have not yet introduced partitioner, by the way. I will first write this program, explain you how do we solve this, and then we'll move on to the partitioners. So let us go ahead and create a class called partition job. Okay, Here I'll be writing mapper guy, reducer guy, and a driver guy. So in mapper, what I'll be writing? Okay. So it takes 4 parameters, as we know. What are these parameters? If you can see the input file, it's a byte offset and the entire record, right? So here the input key will be 0 and the value will be entire record. Same way, out key will be permanent and value will be 100. That is what we are going to write. So what is the corresponding data type? Long writable text. Okay, output key is permanent, which is also text, and this is int writable because it's a salary. We need to select the right import or Apache Hadoop IO, which completes my class. So we have selected int writable, right? Byte, int writable, double writable, all these are there. Long writable is there. Okay, so now we'll create output key. For all this, now I would say request everyone to read a Hadoop Java doc available in org Apache website. Just type Apache Hadoop Java doc. That's it. First link will come, which is a Java doc where you will get to see all the such classes available in Hadoop. Okay, so you have this. Now what happens is I'll be overriding a map method which takes these values. So you'll just say long writable key text value context. Okay. Just say value dot toString dot split. You split it based on the comma. I'll get all the columns. Okay, what I'm doing is I'm taking this value and I'm splitting it, or not comma, it's space actually. So you split it based on the space. So I'm splitting it based on space, and that will give me different columns, and then I'm setting the output key and value. So you'll just say output key dot set columns of two, out value dot set columns of 3. Okay, and here I should be doing %, because it's a value. And then you are just setting the output as, you are writing it output as context.write output key, output value. That's it, done. Okay, this will solve my problem, and this will basically help me write my mapper class, which is going to get these kind of output. Okay, so a permanent or a contract as a key, and the value will be the salary. Okay, that's how we'll be writing the mapper class. So this completes the mapper code, and then we'll be writing a reducer code. Okay, so let us start writing a reducer code. Cool. So let's go ahead. We'll write a reducer now. So here the key will be in reducer. What do you get? This is the input you will get, right? Key is permanent values list of salary. So it should be something like this: 100, 200, 300, 400, 500. Let's say. So text is a key, value is an iterable, output key is text, value is a iterable. That's it. Now let's start writing the reducer code as well. In reducer we are getting text as a key, iterable, values, and text, and then you will just take the sum. It's a code that you need to write to get the average, right? Okay. And finally, you will just say this context.write key value. Done. This completes my reducer. Context will help you to write the output key and value into the intermediate output file. That's the use of context object. Okay. So this is what we are basically doing in the reducer code. Any questions on the reducer code? I'm just copy pasting the driver code because it's safe to do that. Partitioner's job. This is part mapper and part reducer. Can we use a combiner in this program? Very good. We should not use a combiner here because it's an average. Okay, everything else remains the same. Cool. So we are basically setting all the properties: map output key, map output value type, and reducer output key, reducer output value type is also what you are setting here. Then you are setting the input and output path, and then finally you are saying job dot wait for completion or job dot submit. That's it. So now you are going to basically execute this program. So let us do that. Right click, export, and we'll first execute this program as it is and we'll see how the output gets generated. Okay. So let me go to this guy to SDFS and see the output. There is a part input file which is being used here, so we'll be using that. This is the output we are going to generate. It is going to process that input file and write the output here. All right. So let us check the output. Anyway, so as you can see, we got the output average salary of a permanent and a contract employee here. Okay. So that is a one MapReduce program that we executed. Okay. We have not yet really introduced a partitional concept, but we have just executed this particular example to understand what happens behind the scenes. Okay. So let us continue and increase the problem complexity. See, as of now, we got the output in one file where we got average salary of a permanent and contract employees in the same file. These two records, I have it in the same file. But what if I want output in such a way that I should have two different output files like part R000 as well as 001, and one of the files should contain contract employee average salary data and another file should contain permanent employee average salary data. Okay, so that is what I want to do. And if I want to achieve that, what is the bare minimum change we should do? Some of you have already given me the answer. If you want to achieve this, if you want to write two output files, what is the bare minimum change you need to do? We have to set two reducers so that the output will be having two files. Let us do that. Let us set the two reducers. Here, I'll do something like this. Job dot set number of reduced tasks as 2. Okay. Once I set this number of reduced tasks as 2 in the driver code, it will mandatorily take two reducers for this program. So let us go ahead and re-execute the jar. Now I'll create a output again. So I'm just changing one line of statement where I have set number of reducer as 2 in the driver code, and now I'm re-executing the jar. I just want to make sure whether how does the output look like, and if it creates two output file, whether it is able to divide this data into output file or not. So I leave it to framework to do that. I'm just setting number of reducer as 2. Let me execute and check the output. So here it has just executed that. Let us see the output. Okay. If we go to the SDFS, there will be an MR folder under which there is a part out 1, which contains two output files. We are good here. It got two output file. But do we have data also divided into? No. One file has something, another file has 0 bytes. So that means it doesn't have any data. So if you do this path this, you will actually get 0 data here. One of the file will be empty, another file will have all the records. Okay, and another file, if you see, it should contain both the records, right? So this is the problem. Now, this is where you basically need to understand why it has done this way. By setting number of reducer as 2, we were assuming that automatically it should have divided the data as per our expectation. It will divide the data, but it's not necessary that it may be dividing as per your expectation. Hence, it did not divide data for contract and permanent into two different files. Okay. So I have just explained this problem just to help you understand that what was the scenario and why we were not able to divide the keys into two different files. So let's understand that first. In this particular example, when we run that, what would have happened in the background is what we are understanding now. So we know that this is mapper 1, this is mapper 2, they would have generated their own output. Then there is something called partitioner. Now here I am actually introducing a partitioner. So what is the use of partitioner? See, partitioner will always be there, okay? So partitioner will always be there and it will be basically running after mapper phase and before shuffle and sort phase. What does it do, by the way? What is the use of partitioner? The use of partitioner is the moment your program decides to run more than one reducer, it will create that many partitions so that it decides which key and value pair of mapper will go to which reducer. Okay. For example, here, let me draw it in a red color. So I have two reducer, reducer 1 and reducer 2, right? Hence, it has to basically divide the files in this order. So what it has done, it basically start executing a partitioner code. Which partitioner code it is? It is a default partitioner code of Hadoop framework. Okay. So when you take two reducers, what it does, it actually creates multiple buckets here. Okay, partition buckets. Let's say this is one machine, this is another machine's output. Okay, so it will create a bucket here as well. This is bucket 0, 1, 0, 1. Now what is this? See, every bucket, what is a bucket? Bucket is just a file, okay? It's a temporary file which is created in this machine. Every bucket will have some indexes. And that index range will be based on the formula, which is this: 0 less than or equal to index less than or equal to, less than number of reducers. So 0 less than or equal to index less than 2. In our example, we set reducer as 2. So index can be in the range of 0 and 1 only. That's why it has created only two partition buckets in this range only. Okay. Okay. So it has created multiple buckets in each machine as a temporary file, and the index of that file is decided based on this formula. Since you have decided two reducers, it will create two files with 0 and 1 as an index in both the machines. Now, default partitioner code, which is run by Hadoop framework, what does it do? It will run for every output key value from the map task. So let's say first it will run for this guy, and it will decide that, okay, this key value should go into this bucket, P100. Next key value will also go to that bucket. Similarly, all the subsequent key values, right, C300 and C400 will also go to bucket zeros. So all of them are going to this bucket, and none of them were categorized into bucket 1. Similarly, in bucket 1, I have this. Okay, so the default partitioner were not able to divide permanent and contract keys into two different buckets. Maybe because of it is using internally hash code of a key to identify the difference and similarity between the keys. So it may be possible that two keys hash code might be same, hash code collision may occur, and hence they may be put it into the same bucket. That's what has happened here. So another bucket was empty. Okay, this is at the mapper level. Now in shuffle and sort, what happens? All the keys and values of the same bucket will be grouped like this. This is bucket 0 and this is bucket 1. Okay, so all the key values of the same bucket will go into the okay. So as you can see that all the key values of bucket 0 from both the machines are combined like this, all the values for permanent, all the values for contract, right? But bucket 1 doesn't have anything, so it is empty. And that's where finally what partitioner does, it actually sends all the key values of bucket, one particular bucket to one reducer, another bucket to another reducer. And that is the reason why this reducer has empty and this reducer has both the data. So it has generated one file with both data, it has generated file with no data. That was the major reason. Okay. So the partitioner's major functionality to decide which key value pair will go to which reducer, but it also do a lot of load balancing activity as well. So let me repeat what I have just talked about in the index. Most of the people are requesting that. So see, we have two reducers, okay, and that's why it has created two partitioner buckets in each machine. And the index is very important for each bucket. It's just like address or a file name where I should put this data. An index is derived based on the formula, which is this: 0 less than or equal to index less than or equal to number of reducers. So 0 less than or equal to index less than 2. 2 is the number of reducers we have selected. So in this formula, what should be the value of an index variable? Either 0 or 1, right? So these two index buckets are created in both the mapper class. And then what it does, it will basically try to run partitioner, default partitioner code on each key and find out whether it belongs to bucket 0 or bucket 1. And likewise, once you segregate all the data, then all the key values of bucket 0 will be shuffle and sort, will be transferred over a network, and it will be done for shuffle and sort. Similarly, all the key values of bucket 1, since we don't have any, it will go to bucket 1 of shuffle and sort. And finally, all the key values of bucket 0 will go to reducer, all the key value of bucket 1 go to reducer 2, and hence, since reducer 2 does not get any data, it generated a file which is an empty file. So I just explained you why there were two files and one file was empty. Is that clear? Because default partitioner could not divide the data as per our expectation. That is why it was having one file as empty. So now I'll be explaining you how to write our own custom partitioner to divide this data in an appropriate way. Okay. So we wanted to basically write a custom partitioner code. As you can see here, this was the file we have. Now we wanted to write a custom partitioner code in a way where we should be able to divide the data as per our expectations. So what is the bare minimum change we should do? Instead of writing all the permanent and contract into one file, I can write all contract into another file and permanent into another file, right? Another bucket. So in that case, what happens? I will basically segregate both the data so that this is my bucket 1, this is my bucket 0, and it goes to reducer 2. So reducer 2 will get contract average salary and reducer 1 will get permanent and average salary, right? So the crux here is, if you want to divide the data as per your expectation, then you should write your own custom partitioner logic, which runs on every output key value pair of a mapper and then decide which bucket it should belong to. Okay, that's the only check. And here, if we can somehow write a logic which makes sure or mandates that if there is a key as permanent, it should go to bucket 0. If the key is contract, it should go to bucket 1. Then our job is done. That is exactly what we want to achieve. So let me write a program for the custom partitioner code. In the same class, I'll be writing one more component for a custom partitioner. Let's say custom partitioner class has to extend a partitioner class which runs on the output key value of the map method, right? Mapper class. And you need to implement or override one method of the partitioner class. So what we are doing is just like a mapper class, we have a partitioner class which extends the partitioner class of Hadoop framework, and it actually runs it on the output key value type of a mapper. Here output key value type is what of a mapper is what? It's a text and int writable, right? So that is what it runs on. So basically we are actually running that code on this, and then the get partitioner will decide which index I should put these values. Okay, so the get partition method, just like a mapper class will have map method, reducer class will have reduce method, the partitioner class will have get partition method, and it basically decides which this key and value should belong to which bucket. How does it decide? So as you can see, the return type of this method is integer, which means it returns the index of a particular bucket where this key value belongs to. So for example, if I'm let's say this key will be permanent and value will be 100. When it comes here, you write some logic here, and when you return the index as let's say 0, that means that permanent key will go to the 0 index bucket. That's how it put them into different buckets. And the third parameter is number of reducer, which is 2 in our case, right? So let us try to write a logic so that we will make sure that it always divides permanent and contract into two different files. So you can write any type of logic here, okay, and we can always argue what is the best possible logic we can write here, what is the best possible generic logic we can write here. But what I am trying to highlight a point is how to write a partitioner. So we can in fact write a very simple logic to this. If the key is permanent, okay, so that's it. This is as simple as this. This is the only simple logic that I am going to write in my partitioner code. Okay, very simple. I am just making sure that if the key is a permanent, I need to put it in the bucket 1, which means I am returning an index as 1. Otherwise, I will always return 0 for all the other types of keys. Okay, that's the main whole idea. So, and also one more thing you need to remember, that when you write this program, when you return the index, make sure that you don't return the index which is out of the range of these partitions. For example, if you are returning the index here, which is let's say 2 or 3, but your index can fall under only this range, right? As you can see, this is the range where it can fall under. So obviously you should not basically return the index which is outside this range. Otherwise at runtime it throws an error saying that no such partition exists. Try to understand where we can use partitioner and how we can use partitioner, right? This method is, assume it's a black box. You decide what logic you want to write based on the problem you want to solve. For this problem, I am writing this simple logic, and I agree with you that it will not work with huge data sets and different number of keys. I may not be able to decide all this stuff. It's fine. We may need to discuss that. We may need to have have a different approach for that, and then of course that can also be solved by finding out the right approach. This logic will not be useful to solve that problem, but that is not our objective. Our objective to understand is how to write a partitioner code, okay? And another real world application that I want to share it with everyone is partitioner can be used in many scenarios. One of the scenarios is, let's say, in a financial world, in transaction world, you want to find out how many transactions are fraud. Okay, and specifically you want to find out how many credit card transactions are fraud or how many debit card transactions are fraud. And these things, when you want to solve, you see, when you get the transaction data, you get both bank and card data. So how do you actually distribute, or how do you basically, segregate them, whether this is a bank transaction or a card transaction, and how do you decide a fraud? So that's where partitioner can be useful, right? That is one real world example. Like that, whenever you have such kind of requirement, you should think of using a partitioner. So in our case, I am just using a simple logic to divide both the keys in two different buckets. Cool. So let me go ahead and execute this. But first important thing is, this is just a partitioner class you have used. You have written, by the way. Where are we using it? So we need to reuse it in our driver class. Okay. So I have to also code it somewhere here in the driver, something like this. For example, I'll say job.set partitioner class as custom partitioner class. Okay, this is where you are telling Hadoop framework that don't use your default partitioner logic, but use my custom partitioner logic to divide the data. Okay, and that's where Hadoop framework is going to call this method to divide each key into different partitions. So let's try to execute this program and see what happens. I'm exporting it as a jar. And let me execute the same thing. I'll change the output folder and let's see what happens. As you can see that I got one file which contains contract data. Okay, and another file should have a permanent average salary. So that's how we are able to successfully divide the data into two different files using a custom partitions. All right, so let's get going. Now I'll show you how to debug a MapReduce program. We have seen number of MapReduce programs today. So let us go back to the first. I'll show you how to debug it using log files, and then I'll show you how to debug it through Eclipse. Okay. So let us go to the. So I'll open a browser, and in that there is a bookmark tab called Yarn Resource Manager. So when I click on that, it actually opens a Yarn Resource Manager tab which contains multiple jobs. So I'll go to one of the applications which have run here. For example, let's say it has run this partitioner code. So if I go to the history, and it will open that stats of this job, like what is the job name, when it is executed, what was the start time, end time, how much time is lapsed, average map, reduce time, and then finally it says map and reduce task. Okay, so you can see that number of reduce tasks were 2, right? So there were 2 reducers executed and 1 map task executed. So if you click on the map task, it actually opens a task ID. Okay, this task ID is a map task ID. So if you click on it, you can also get other details about that map task and status of that map task. If you click on that map task, it will show you the task attempt ID. Okay, so as you can see, the first task will have _0, which means it is attempted first time, and it will say that first attempt is actually executed in this particular machine in your cluster, and what is the status. If it was not successful, it would have attempted one more task, and you would have another attempt ID for that, and it would have told where, in which machine it would have executed that. And you can go to the logs. The logs will get us the actual data. error, out, standard out, and syslogs. Okay. So the error, if there is any error, it comes here. So standard out is where we can write our own debug statements or log statements. It will be printed here. And syslog means all the logs which are generated by system, that is being printed here. Okay. So that's how we see the logs of the map task. Same way you can go to the reduce task and you will get two task ID, two reduce task ID. Because there were two reducers generated, you can go to any of them and see the logs. Right now it will be system generated logs only, nothing else will be there. Okay. So what I will do is, now let me put some debug statements and we will re-execute the job and we'll see where the logs will be printed. So I'll put a debug statement in every mapper as well as reducer. Map out key okay. I'm printing output key and output value, okay, for every line. Same way in reducer also, I want to print the reduce out key and value, okay. And you can also print here in the partitions. So you can just say partition executed on key is this and the value is this. So we'll get to know that on which key value this partition is going to be executed, right? And bucket index equals to, I should just do something like this, index equals to 0, index equals to 1. Okay, so we'll also get to know that for which key value this logic is executed and what bucket index is written for that. Alright, so this is the debug statement that I have put in everywhere, and then let us try to execute to check where it comes actually, in which task, and how do you see those statements. So I'll be re-executing this jar again. Let's see what happens. As you can see, this is the job ID. See, you all should be aware of the actual job ID. Based on that, you can easily check your logs from the resource manager page. Okay. Or in fact, on the resource manager page, you can also see the jobs name as well, based on which also you can get to know what is the job. See, job name you would have printed here, partitioner. That's the job name which should be listed, based on which you can find out this is my job which is being executed. Okay, so we got that output. Doesn't matter, the output will be the same. So let's go ahead and go to the resource manager page. We get this job and we'll go to the history of that job. We'll see different map and reduce tasks. We'll go to the map task, click on the map task ID and click on the logs. You can see that for every, this is std out, which is your mapper logic, mapper output. So for map output key permanent and value 100, it calls a partition for that. As I told you, for every output key and value, partitioner will be called. Based on this, now you can know the execution sequence also, right? So it will say key is permanent and bucket index will be 1. Permanent bucket index 1. If there is a key is contract, bucket index is 0. Like that, you can find out which key belongs to which bucket index. Okay, and as you know, for every map output key value, the partitioner will be called after that immediately. Okay, So from that log statement itself, you can check the execution flow. Now you can go to the reduce and you can go to any of this reducer. Let's go to the one of the reduce tasks and get the logs. So it will say reduce output keys permanent value is 4418. Why? Because see, because of the partition, only one key value would have gone to this reducer, right? If you go to another reducer, it would have data for contract keys, contract employee data, right? So it would have had reduce key value as contract and average salary. So that's how you can actually see the logs in MapReduce jobs. All right, cool. So let's go ahead and debug it in Eclipse. So let's debug this word count program in Eclipse. Any program you can debug. So we will basically load a data. See, I have a fruits file available here. This is my local file system path. So I should be giving this path as my local file system path to debug the program. Okay. When you want to debug a program in Eclipse, there are a couple of things you need to do. See, you already have written a program and it has a main method, which means definitely you can run this program in the Eclipse itself. But to do that, it needs to have a certain runtime libraries which should be imported in the class. Okay. As well as you need to set some, see, for example, every MapReduce job that you are executing here, you are giving input path and output path, right, for a MapReduce job. So these input path and output path, you are passing it as a command line arguments, and then internally the job MapReduce program used to handle it. But if you run it through Eclipse, then how will you pass that command line arguments? So that is also possible. You just need to right click, either right click here on this class and just say debug as, or you can right click on the code anywhere and just say debug as. Okay. Debug, go to the debug configuration. I will basically go to the, see, when you create a new application, it creates this guy, this debugger, and then it says this is the main class, this is the project, and this is the argument for it. So here in argument section, you can pass those command line argument. So I'll be giving input path as my local file system path, and output path is, let's say I want to create an output under this MapReduce folder itself. So I don't need to give any path, directly I'll say WC output. Okay. If I don't give any path as prefix, automatically it will create it in the same working directory where this program is going to run. This is my input, this is my output path, both are local file system path. Okay. Now when I start debugging it, let's see what happens. Let me start debugging it. So it will open a new perspective, debug perspective in Eclipse. I'm sure many people will know what is debug perspective. So it will basically, give you step-by-step executions of your program. Okay. So looks like there is some issue. Okay. Let me go to the console and check what is the issue. It says no class def found error, commons logging log factory. So this is the problem. So basically, this particular program when you run, it is actually going to be needing lot of libraries at runtime. So you need to import them in the class path of this project. Okay. See, in Hadoop cluster when you run it, it will have its own class path set. But here in Eclipse, you need to actually import all these libraries. So the easiest way to import all the library is go to this project, and I don't want to selectively, decide which library to be imported. I will just go to the build path, configure build path, and I'll just say add external jar, everything. Everything under usually Hadoop client 020 folder. I'm going to add it and then just say OK. That's it. Now I should be able to debug it without any error. because it doesn't really have any issue with the library. So now I'll debug it as a Java application again. When you do that, when you debug it as a Java application, let's see what happens. Okay, it has been executed. In fact, sorry for this. I have not put any breakpoint, and that's why it is executed successfully. So I wanted to put a breakpoint and show you how does it execute. Okay. So let me refresh this. It should create WC out directory. Let me delete it again. I'll just delete this and I'll restart it. Okay. I'll re-debug it, but this time let me put a debug point. I'll put a debug point at, let's say, here, and let's say in the reducer also here. Okay. Once you put a debug point, what happens? When you debug the application, it will stop the execution at that point. And then as a developer, you can decide how to go after this. Based on your control, it will move further. As you can see, it has started, showing all these debug statements. See, it has just put map as now. Wherever you put a debug point, right? All of you can see here. There actually it has basically executed. It has come there actually, and it has stopped there. Okay, you can see it here. So now I can just put F6, which will, move the line forward, execute the which will basically move the debugger forward. And you can see these words will have this data. Okay, I will have array of words which contains this data. Now under this, I'll just say for every word orange comes, I'll set it as a key and value. Key is orange, value is 1. Similarly, the next word comes, which is apple, and the value will be 1 only, obviously apple and 1. So that's how it does it for everything. Okay. So now I'll be coming to the next line because first line will get over. Okay. Next line will also be the same. So I'll just do F8, which will come out of that. I have removed the debugger and now it came to the reducer. So as you can see, map is 100%, reduce is 0. So now reduce has started. But before it starts, I want to debug and check what's happening. Right? So it just, I should not put it here, I should put it here. I'll just put F8. So it just say key is apple, value is 40. If I put F8, for the next key, which is banana, it has taken the total sum, which is 45. Similarly, if I put F8, it will get new key, cherry, and the value is 16. If I put F8 again, grapes, value is 32. That's how you can debug it basically, right? That's it. And if I close it, if I remove the debugger and if I close it, it will basically finally complete everything, and your map and reduces should be 100% completed, as you can see here. Okay. There is one normal, warning that comes, which is HTTP method. It doesn't matter. It's not required, so we don't need to worry about it. So it will execute it and it will complete your execution. Now we'll move forward to the output. Let us go and see the output. So as you know, we have created we have given the output path under MapReduce folder only. If I refresh this, I should be able to see the directory created as WC out, under which I will have part R00 file, right? Which will contain the word and the occurrences of that word. Yes, Sumit, absolutely right. So you don't need Hadoop cluster to debug MapReduce program. You just need Hadoop libraries, and you can debug it in your single machine. You don't need Hadoop clusters for debugging any MapReduce programs. Okay, you just need Hadoop libraries. Cool. So that's all I had for today's session. So thank you and have a good day.